Hello everyone, this is Randall Warnes from FLIR SUAS, and this video answers one of the most common questions we get about aerial thermal imaging, which is, what can I see from my drone? In this test, I compare imagery from the Zenmuse XT based on the Tau 2 core, which is found in the View Pro, Duo Pro R, and Zenmuse XT2, and the FLIR Duo camera based on the Lepton core. Thermal resolution is lower than that of visible light cameras. The XT has a resolution of 640 by 512, which means there are 640 pixels horizontally and 512 pixels vertically. This gives you over 327,000 pixels within the image. The Duo has a resolution of 160 by 120, which gives you just over 19,000 pixels. That's 6% of what you get with the XT. When you're locating or measuring something in thermal imaging, you want to get at least 5 by 5 pixels on your target. The subject of this test is a 16-inch pizza pan, which is heated up to make it easy to identify. This is slightly smaller than a person, but as you think of the subject that you'd like to assess or locate, this can be used as a guide. Now before we go into the imagery, here's a table that provides you how much space in inches each pixel represents on the ground from various altitudes. For instance, if you're using a 160 by 120 camera at 100 feet above the ground, each pixel at ground level covers 7.5 inches. Whereas the pixels of a 640 by 512 camera at the same altitude represents 2.3 inches on the ground. When you consider the minimum for reliable detection and measurement, and that requires 5 by 5 pixels on the target, you're able to locate smaller objects with a higher resolution camera and with greater detail. This chart depicts the smallest detectable object in inches from various altitudes. So at 50 feet, you would reliably be able to detect objects that are 18.5 inches in size with a 160 by 120 camera, and as small as 5.5 inches with a 640 by 512 camera. These tables can be really useful to determine what altitude you're able to fly, or if the camera will be suitable for your application depending on your target. Now let's see what this looks like. At 25 feet AGL, the pizza pan is very noticeable in both inches, and you could also notice the cracks on the pavement with the 640 by 512 camera. As we move higher, the space on the ground each pixel represents increases. At this altitude, we're still able to get good identification with both cameras. At 75 feet, the 160 by 120 camera starts to blur the target, and although it's still visible, this is already too high to get reliable measurement and detection of a 16-inch subject. The 640 by 512 camera still has no problem, and even the cracks on the pavement are still visible. As we move higher, you'll start seeing even more variation between the clarity in the two images. At 150 feet, this exceeds the maximum altitude with this particular field of view of the Zenmuse XT that you'd want to fly to reliably measure and detect an object the same size as the target here. You can see just below the target what a person looks like at this altitude. As we move higher, the 160 by 120 imagery is only picking up very large objects, where the 640 by 512 camera still provides significant detail. However, keep in mind that even at this altitude, where the target is visible, it would be very difficult to detect and measure this target at this altitude reliably. You would likely want to fly lower to ensure you don't miss what you're looking for. At 300 feet, you can see that even cars are difficult to identify with 160 by 120 imagery. As we move up to the maximum allowable altitude for small UAS operations, you can see how important resolution is to your mission at using thermal imaging cameras. Hopefully you found this video useful. If you have any feedback or further questions, feel free to reach out to me at randall.warnes@flir.com. Thanks for watching.